Welcome to Coding with Tom. Today we will be adding perks to our Castles app. Perks will have a cooldown time. To display this to the user, we will use a circular progress view that will be constantly updating. Let's begin by creating the perk model. A perk will have a name, it will have an image name, and a value added. It will also have a type to determine what type of value it is adding to either the castle or the player. Let's move on to the Perk Service. As usual, our service will expose a publisher so we can keep track of the available perks. We'll also enable the possibility to use a perk. This will reset the cooldown time. As usual, our service will have a shared instance. We'll have our source of truth as an array of perks that we will be retrieving and saving. I will skip over the retrieving and saving since we have already done that. And we will communicate the updates to our perks through a current value subject publisher. When the user uses a perk, the only thing we need to do is modify the perk's last use date and store it again. Because we will be showing the user the outcome of using a perk, we need to modify our enum outcome to include when we increase the gold with the harvest or when the attack perk is used through the smith. We'll be using a single use case for the perks. In case of the gold, we will just be modifying the gold with the kingdom service. And for the castle, for the attack perk, we will be modifying a random castle. Since we added 2 new entries to outcome, we need to add new views for them. Our perks will be shown in the action cells. For that, we need to modify our action view model to cope with both types of items. Now that we have our services and use cases, let's go to the dashboard view model and start getting and using the perks. We will need a Perk Presenter to transform our Perk into an action view model, and that way be displayed in an action cell. Since it doesn't make sense to add a perk with a cooldown of a date that already passed, we will only be adding start date and end date when the end date is in the future. When our view model has a cooldown, that is, it has start date and end date, what we're going to be presenting is the progress view. Our progress view will really be just a UI Bezier path that will be drawing an arc according to the progress. So if the progress is 100%, it will be drawing a full circle. If it is 0, nothing. To draw this circle, we will be using add arc. Now, if we look at the documentation, you will see that the circle is drawn. We'll start at the beginning at 3 pi halves, and then we'll be going clockwise as the progress increases. Now with this progress view, let's create another view, which will be the blocked progress view. This will be the view that we will be adding to the castle cell. It will have a dimmed white background, and right in the middle, it will have the progress view. The true importance of this class comes through this method, where we will be constantly updating the progress of the progress view based on the dates that we are getting passed. To constantly update the progress view, we will use a timer that will fire each half a second. We will again make the calculation of how much is left towards the end date and update our progress view with that fraction. With that view ready, let's add it to our action cell, only when there is a start or end date. We need to make a few changes in our view model. First, we made a mistake. We need to add the add castle action first and then the other perks. We still want add castle to be the first thing that the user can do before the other things. Let's tap on the harvest. We do get our gold, and our progress view is being displayed as expected. Same goes for the Smith perk. However, when the cooldown ends, the block progress view is not getting removed. So let's fix that. Let's add an ID to our action view model so that from the action cell we can check if we have already triggered a timer for the progress view. We will check for this ID in our action cell. If that value is null, then we will determine if we fire or not a timer, else we just return. Let's try again. And when the cooldown ends, the progress view goes away. Now you might be noticing a weird behavior here when we are scrolling or keeping a finger down on the view. The timer is not being run. The progress view stays frozen. That's because timer by default runs on the main thread, and when the user is performing an action on the main thread, the timer stops executing for that time. So let's fix that. Instead of using these class methods from timer, we're going to be creating a timer, and then to make it run, we add it to a run loop. In this case, we use current, we add the timer, and for mode, we add common. And that should fix the issue. Let's go, let's start scrolling. You can see even though we're scrolling, the progress view keeps updating itself. And that was all for today. Adding the progress view was really simple. It's just creating a UI Bezier path and then deciding how much of the circle we were stroking. Timer is a very powerful tool, but you need to be careful with where it is being run and how often it's being executed. Keep in mind that even though we specified the intervals at which the timer was running, the operating system is really the one firing it, so it may add a little bit of tolerance, so don't count on it being executed precisely after each interval. Hope you liked it. Bye.